All right, so last time we managed to implement really basic networking using sockets in C. And what we did was just sending a message from the server to the client and trying to read one message from the client and print it on the server. Now, the only issue is, I guess it's not really an issue, but it's like you can only send one message and then the server stops, right? So what we would like to do is be able to respond to one client and then be ready to respond to the next client. And to do that, we don't really need like any, let's say, multi-threading, or we don't need here anything special. We just need to add like a while one, right? Like a while true loop, and then just put this entire block in a while loop. So while we can accept a connection, we send a message and we receive a message. And basically, I mean, HTTP would work something like this. So we read the message, we do some stuff with the message, right? And then we send the response back to the client. So that's how HTTP should work. We don't have like a really advanced, like messaging or stuff like in a multiplayer game. It's just one message comes and one message goes back to the client. At least that's how I think it works. So yeah. But yeah, I mean all the TCP and IP stuff is gonna be handled by the syscalls, right? So we don't care about that. We just care about getting the message and sending a message back. So that's the goal. Now, if we take a look at what happens if let's recompile main and run it. What happens if we run a curl command? I get, is it the wrong port? Yeah, so port 8001. Okay, let's stop it, run it again, and let's try. So it responds with this thing, right? And also a new, I guess that's kind of important to know. It's like a trick in HTTP, I'm not sure, but we have all of this stuff in a curl message, or I guess HTTP message. We have the verb, right? The path, the protocol, whatever, HTTP 1.1. I don't think it's that important for us. We can just ignore it, pretend it's not there. Then we have, I guess this is like a list of headers, and then is a new line, and this new line usually separates, I guess, the body of the request in case it's a post. So if it's a post, you can have a body here, right? And that's the reason of having this extra new line here in HTTP requests. So yeah, I guess we just have to parse this stuff, and then my goal is to have like a file-based router. So we'll look for the hello file or hello directory, something like that, and we just send the contents back to the client. So that's my goal. And I guess to make things a bit easier, I have this ds.h library, which is like my own stdlib for C with common stuff, and we have like string slice to be able to tokenize strings easier. We also have, it's not written here, but we also have argument parser, like the one from Python, if you know argparse. It's pretty, I would say it's pretty nice to use if you need something complicated. But like if in our case we just need, two arguments, the folder and the port, so might be overkill to use this one, but still nice. Anyway, let's try to get it. So we just wget this file, right? And that's why I think I mean I started to like this approach of having a single header file for libraries. It's pretty cool. You just download the file. I mean, it's huge. It took us like a couple of days to implement it fully, but yeah. And I mean, I didn't do everything on like video, so there are quite a few things that I did on my own, but yeah, most of the, let's say, data structures, we did them together, so that's pretty cool. Anyway, to use this ds.h thing, so ds.h, you just have to import it, right? And you need to define these options that we plan to use. And as I said, we need the string slice. That's one that we need, so we define DSSS implementation, so string slice, and now we can just use string slices. And we might in the future use argument parser, but for now let's just leave it like this. So let's see. I will just say ds string slice. I think this is the let me check its type def. Yeah, so we can just use it like this. So we'll say, I guess, I wanted to say buffer, but let's say request, right? So then we can say string slice init. And the way I implemented it is you can use your own allocator, or you can just use malloc in case you need to allocate memory. So I guess like Zig, if you are into that kind of stuff. So yeah, here we pass the pointer to our string slice, the char star that we need to let's say tokenize or do some processing on the string slice, and then the length of that string. So it's pretty simple. We just do request like this, then buffer, and then yeah, I guess we went the easy route here. Maybe we can define maxlen 1024, and let's say here maxlen. Now sure, would be much better to just have a dynamic buffer here, and for that sure we can use ds.h, but I think it's fine for now to just assume that we won't have messages that big, hopefully. I mean, who knows, but yeah. And the next thing that we need here is the length of the buffer. So let's just do I forgot I want to say that I forgot what I said here to use. It's like unsigned int. Okay, fair enough. Unsigned int. Oh, and correct me if I'm wrong, but I think this returns the number of bytes that were read. Okay, fair enough. So we can just say int result, maybe. I mean, we already have result, but we can just redefine it. Then if result, I guess it's equal to -1, then we have an error. But I'm not sure if we want to crash this thing, or maybe just say, okay, we had an error on read, and then we just continue or something like that, right? That seems a bit like a better approach. And then in case we have buffer len, it's gonna be basically result, right? Can we say here, well, we read buffer len bytes, and this is the buffer, just to see it. And here buffer len. So if we try to run this thing again, and I guess we can use curl. It says 82, so maybe this was 82 bytes, right? Let's do netcat, and let's say hello, because I'm pretty sure this is gonna be 6. Yeah, nice. So yeah, seems like this works. And now we can do stuff like string slice tokenize, and here we need request. Delimiter is gonna be a space, and here we need token. Well, I forgot, this should be a pointer, something like this, and we can have token here too. So I guess initially this is gonna be like the verb, right? Then we have the path, and then we have like headers and stuff that honestly we don't really care about. Like, if you think about it, yeah, we just care about this one. So should we ignore them, or should we just check that we are not getting, you know, weird ass stuff? This works too, why not? F path requested. Oh, and yeah, share pointer path. We should use ds string slice to owned, and here we pass the token and the pointer to our path, which can be like null or something. It's gonna be allocated automatically. So path requested, right? And here we can just say path. So I'm expecting to see like hello, right? Yeah, path requested is hello. Okay. But now I'm also curious how the response should look like. Because I'm pretty sure it needs to have something like, you know, like this inside of it. Because yeah, if I do like a curl google.com, it's interesting. What if the response is just plain text? Like, I never thought about it, but yeah, who knows? Anyway, should we try it to just write something? But I mean, here we write hello. Let's try to use 2 new lines. I mean, HTTP response error. Like, how does an HTTP response look like? So it should contain the HTTP protocol, the status code, then I guess it contains some headers, then the new line, which again, as I said, it's like a splitter between probably like headers and the text itself. So yeah, let's see. So maybe we can even build this kind of message. So but first let's try to do something like this. I don't think I have this string slice. I have like trim and so if string compare between like verb and get is not 0, sure, like handle the error, probably send a message to the client, but we don't really have to do that. I guess dslog error. We should use these functions. Alright, it's like instead of handle error, we could use ds panic. Oh, just replace this, right? Yeah, whatever. P-error should probably be better. But yeah, I mean, doesn't matter right now. Panic is interesting. What does it do though? I forgot. Oh, so P-error is still nice, but I just need to find that function that converts. Anyway, let's say we don't need that anymore. So here we take the verb, we just say, okay, it's not a get request, so maybe a to do respond with 400, I guess, because it's a bad request. The path requested seems fine. Then I would say char star protocol, probably. Which should be most of the time like HTTP protocol. Let's see again what progress did we make to handle error. Yeah, not sure how I can I don't know, I have this weird thing that I hate about Tmux. If I go down and I press up, it sometimes it just jumps it has like this cooldown after you press the combination, so yeah, it's annoying as fuck. Oh, here we should split by new line. Okay. So to get the protocol, we split by new line. Fair enough. Right, so we get the path, the protocol that we need to put back into our response. So let's try to build the response. Right, so it's gonna be the protocol, then we should do 200, okay, right? Then we do content type. That's interesting. Content type text HTML, I would say. Content type, yeah, like this. Text slash HTML. I don't know if we need other stuff, but content length is probably required. And let's say %d because we are gonna type that. Then we need 2 new lines and then the content itself. I'm not sure if we need all of these other headers like date. I don't know, we'll see. Oh shit, I mean, we can just use this printf to calculate how big this thing is gonna be. That's also something I like to do. So something like snprintf. And a trick that I found with snprintf is that if you use it with 0 as the size, it gives you back how much you have to allocate. So that's pretty cool. It's like a trick that yeah. So this is gonna be the format. Then here we can pass 0. And then for this stuff, let's say we do protocol. Imagine like someone sending weird stuff just so it hacks our app. That's pretty cool. Okay, let's say we say hello. So we do 6 and then hello new line. Doesn't matter though. And yeah, like this stuff should give us back how much we have to allocate. Right, at least that's how I remember it. Wait. No, yeah, it doesn't make sense. It should be something like format comes here. And here we can say something like response. And then char star response is equal to null. And then response len. Alright. Oh, actually here we can even say null just to... Yeah, that's how I think it works. So then we can just copy paste this stuff again, which I mean I don't really like, but whatever. And here we can like allocate, and let's say we do response len size of char, so it's gonna be empty. Then we can pass the response here. I mean, yeah, it's pretty weird that we have to do it twice, but whatever. Yeah, sure, we can use string builder from ds.h, so that might be easier. SB, so we can do like ds string builder, a response builder, we can initialize it. Let's have to pass this stuff. String. Oh. Can't I just, yeah, we can append, that's cool. So we put the format, okay, yeah, perfect. So here we just say this stuff. And here we can just put the entire format string. So it should just take care of it for us. It's like, it does the exact same thing. I mean, whatever, kind of the same thing. I don't remember what append n does. Yeah, whatever. Append is much cooler, so it's like does the entire stuff. Okay, so then we need this string builder. I think it's like build. Yeah. So we pass the string builder here and the pointer to a response. So responses can be null. Yeah. And then pretty sure this, no. We just have to str len the response. Let's write response len. Imagine if it works first try. Huh. So something went a bit wrong. Let's say we print f response. I just, yeah, like this. Wow. I'm a bit curious how the response looks like. So it's gonna be http. Oh shit. Something went wrong indeed, yeah. But I wonder why. I mean, let's be real here. It's gonna be http slash 1.1. Like, I'm not sure if it matters. Okay, so now we get the response back. I don't know why. Yeah, so let's try to respond with http 1.1 all the time, so we don't care about the protocol. So it's gonna be something like this. right? So like we get back the response from curl, which is pretty cool, right? So yeah. Now the only thing that we have left to do is to check the path. So here we got like hello, right? So we just have to check that path if it exists or not. And yeah, like read the file and send it here instead of just a hello message. So for that I have this should be something like IO, this IO implementation, and that just gives us functions to read and write to file. So ds.read. So this function basically. But this is like the happy case of I don't know, assuming that the file exists, right? So let's just say here that we try to read from the, and now this is interesting because the path starts with a slash, so we kind of want to start or I guess do our path without the slash, right? So that's something we can do like this. So we skip the first character. It's a bit scuffed, but doesn't matter. And let's say here that we have content, right? So it's gonna be char star content, and we need the address to it. Sure, this thing can fail, but let's imagine that we are gonna have the files, right? Because like if this thing fails, then let's just say we need to return 404. So we can do here to do if file does not exist, return 404, right? Makes sense. Oh, I have an idea. So this is like the happy case. I just wanted to put the response there in case it's I don't know, but now let's just focus on reading the file. Oh, actually we read it. Content len, right? So we get the content len and the content. So here let's just say content len and content. So this should be everything. Right. So if now we make a hello file, hello world, and we start our server and we curl hello world, we get the contents of the file, which I mean pretty cool, right? It starting to look a bit more like http server. Like if you know http server, it even has logs and stuff. That's cool. But yeah, it works exactly the same. So yeah, that's what I'm trying to emulate. So now we are pretty close to that. So yeah, so it responds to our curl request. So yeah, I mean, if you are interested to see more stuff like this, yeah, don't be shy to give me some ideas like what else we can do with this app, because yeah, I guess I'll try to add some logs, maybe more error handling, and yeah, like a bit of safety in general, because right now it's we just assume that you are gonna do the right thing. So if you are gonna do something like curl something that doesn't exist, like hello slash world, it's just gonna fail to open, but didn't really give us back let's say 404. So that's another thing. And I guess the other thing that's cool about http server is that if you do something like this, it gives, I don't know how it builds this thing, but it builds a directory listing. So in case we find a directory, we should build the HTML ourselves like this, which, yeah, pretty cool. And the other thing is that I'm pretty sure that if you request a PDF file, it even knows how to respond with content type application PDF instead of HTML, so that's another thing. So yeah, but for now I think this is pretty decent progress, and yeah, we'll see in the next one. So see you.